I'm Ino Aurora with Net Security. ThreatResponder is an endpoint threat detection, prevention, and response platform. One of the core capabilities of the technology is the ability to do malware analysis on any malicious binary. So in this demo, I want to show you how you can use ThreatResponder to do malware investigation with just the click of a button. Let's go. Let's say you have a malware that is running on an endpoint or that you want to investigate. All you have to do is log onto the ThreatResponder platform, and from the dashboard, simply select Melissa. You have the option to scan a file, so by uploading the file to a system to be analyzed, or you can define policies, right? So with policies, you basically define you basically create a file that you want to the policy you want to create, describe it, specify any file that has a specific hash, or specify a signer, right? So you may say, you know what, any file that is signed by any company or by a specific signer, you want to automatically analyze it. Or you may specify a file by its name, by the file or file location of the file in question. So you may say, you know what, any file that is running in a particular directory, you want to automatically analyze it. Keep in mind, you don't want to analyze all possible files in the system, so you have to be specific because it could be resource intensive, right? If you are, for example, analyzing every piece of exe that runs on the system, right? It will not be efficient to do that, right? You also have the option to basically specify the execution period, right? So some malware may take time to run, some may just run for a few milliseconds or a second. You have the option to define the malware in question. And you can also specify an endpoint or group of endpoints, right? So if a particular endpoint is being compromised or is running a malware, you may say, you know what, I want to run the analysis or run the malware analysis on that endpoint or group of endpoints, right? So that's all you have to do. Once you define all of these parameters, you apply to an endpoint, and then you basically save the analysis. And once a file or files that trigger all of these, any one of this, whether through the hash or a signer or path or file name, the file is gonna execute, the malware is gonna execute, or the binary is gonna execute for the number of seconds you've defined, and the results will be rendered to you. So going back to the investigation or the scanning or analysis that we've already done, we've done it on specific files, right? So in this case, I am going to select one of the ones that we've done in the past, right? So here is a file name, here is a command that was executed as part of the malware. Here is the number of detection. So we try to match the detection with other AV engines. And here is the status of the analysis. In this case, it says they are all finished. In some cases, if analysis was just started, it will say running. And this was when the investigation was actually created. This is the endpoint that the analysis actually ran on. And this is a policy, right? So a link is basically well, you have two options, right? So the not applicable is when you specify a file to run in a specific location, and I think this is basically when you specify a particular. I'm drawing blanks here, right? So I have to look into this to be able to tell the difference. But at any rate, so in this case, right, we ran Chrome, right? Chrome is a non-good file, right? But for illustration, we did an analysis on Chrome. It could be any binary, right? So we have the zero engine detected, right? So the MD5, the SHA, and this is the property of the file, right? The icon, the story. We have the option to tell the story of this execution. Telling this story basically gives us more insight into activities of this particular process, but for now, all we are really interested in is to basically illustrate how ThreatResponder is able to provide a lot of visibility or insight into this particular binary. It doesn't have to be benign. It could be malicious, obviously, right? So in this case, it's benign. So there was no detection with any AV, and this was a file size. This was when it was a analysis or was actually conducted, and this is the version information, right? So it was the company name is Google. It's copyrighted information and so on and so forth. Now, keep in mind some of this can be modified, right? But the key thing is that to be able to detect whether the file is signed, right? And here are the metadata. So you have the entropy, the file type, the MD5 hash, SS deep, and again the file size, right? This is the environment in which the analysis was occurred, and we matched the any detection against virus total, and there was actually absolutely no threats. No engine detected it, right? So again, these are the signature, these are the signers, as well as the any counter signers, right? So we can tell that this program was actually legitimate, right? And nonetheless, the portable executable information, this was when the file was compiled, and these are the number of sections, the entropy point, and any exports, right? Any export functions. Here we also have import functions. These are the list of import functions that we're able to determine from the analysis, and so the import functions with DLL, these were the functions that were used in the kernel 32 DLL. In the Chrome EFL DLL, these were the processes that were, these were the functions that were imported, and the version DLL, these were the functions that were also imported. These are the sections, showing the entropy, the hashes, and the name, so the test, our data, as well as the raw size, the virtual address, and the virtual size of each one of these entropies. Another thing that is of interest is the process tree, so how the process was executed. In this case, we have the process tree, and basically Chrome was launched from the Explorer, right? And again, the signer, we can't overemphasize that, and then the child processes, right? So typically, Chrome will invoke other child processes when you open a tab, or when you say when you decide to open a page on a different tab or in a different window altogether, right? So all those are child processes. And we also investigate child processes. So in this case, the Chrome has zero detection. So that is a good thing, but that may not necessarily be the case for a malware. Right? And here is what really gets interesting, right? So we look at all the functions, all the behavior of the file, right? And we basically match the behavior to the MITRE attack matrix, right? So you have the initial access, execution, persistence, all of the catalog, the MITRE catalog entries. We basically try to pinpoint when there is a match, right? So this is how we match the detection to MITRE, right? And then there are some indicators that we've identified, right? So even though the Chrome is not malicious, but nonetheless, there are some categories that we've identified. For example, it deletes file, right? We know that it downloads binaries from the internet, and it deletes temporary files if they are no longer needed, right? And then you have summary, right? So it contains functionality to adjust token privileges. It contains functionality to enumerate list files inside a directory. Yeah, so these are all legitimate entries. And these are the details of each of the categories, right? So you have the description, details, severity, and then issue. So basically mapping to the MITRE, right? And then we have screenshot, if any, and we have the ability to download any of the screenshot, right? And memory forensics, if any, was performed. We also have the ability to download all strings and identify some of the strings. So within that Chrome exe, we're able to identify some URL associated with that was actually inside that file. Now, for system resources, all we're doing here is basically tell you the system resources when the Chrome was analyzed. So it really, from a threat standpoint, it's really it really doesn't tell you much. Nonetheless, it tells you if the process consumes a lot of resources or uses a lot of or doesn't, right? And then we show connection map if there were connection to any location, and also we also show you files that were accessed, that were created, that were deleted, that were modified. In fact, if this were a malicious software, you're able to determine the files capabilities of the malware by not spending the time to do full-blown malware analysis that's going to take days or even weeks to get resolved, right? So by just click of a button, I was able to do a detailed malware leveraging dynamic and static analysis to do the investigation. I also have visibility into registry keys that were created, deleted, renamed, values set, values deleted, and also process handles, right? Loaded modules, and so on and so forth. So for this analysis, I'm able to, I have the option to download the JSON format, JSON file, or the PDF, or the CSV, or even XML, right? So if you ask me to do forensic investigation on the Chrome or any binary, I have the ability to not only do the analysis, but also to provide the results. Another analysis I want to show you is is this particular binary, right? This one was actually was done, and there was a detection, right? So 60 engines detected this file to be malicious, but we have the option to basically investigate, and again we can download any of the format that we want, and this is the file size, the date it was executed, these are the properties of the file, as well as the version information, the file metadata information, the environment in which it was ran, and some of the detection, right? So according to VirusTotal, for example, 60 of the 68 AVs basically detected this file to be malicious, right? So that's really, really is interesting result, right? So we not only do the analysis, we also look at all our threat intelligence sources to give us information about what it's saying about the threats, right, or the binary in question, right? So we have information about the portable information, the import functions, as well as the sections, and then we have the process tree. So in this case, this process was detected, it's unsigned, and then the child processes. These are normal Windows processes. So the exe or the binary basically uses called the ICOX, which is a Windows process, as well as attrib to be able to do some of its invocation. Basically, it invokes these legitimate Windows processes. Again, the MITRE attack matrix, we try to match the behavior of the file to MITRE attack matrix, and we're able to highlight any possible match, right? And another thing that is of interest is are the indicators, right? So again, it uses cryptography. There's a summary section, obfuscation, hooking, anti-debugging. So these are pretty interesting malicious behavior, right? So you have the description of each one of these functions and the details as well as the severity, right? And if there were a screenshot, we would have captured it, memory forensics, and also we have the option to download the strings and things like that. There was no connection to any network, and as the connection was there was no connection to any network whatsoever. If there were, the list of connections would be shown, DNS resolution would be made, and any HTML queries will be provided, right? So also in terms of file access, creation, deleted, modified, we also provide the capability of the files that were accessed, files that were created, deleted by the malware, modified by the malware, right? So this was some type of ransomware, right? So there were a lot of files that were renamed or created rather, or modified rather, right? So on the endpoints. Another thing that may be of interest is the registry. If there's any registry keys were created, renamed, or deleted, right? We also have the ability to list all the handles, so the attrib and ICACs that we talked about previously, and these happen to be legitimate processes. We have the option to drill into more detail to gain more insight into attrib or any of these processes or handles, but we won't do that right now. The other thing that we may be interested in is the loaded modules. So here we have names of all the modules, the paths, and the signers, and so on and so forth. So ThreatResponder really gives you the ability to do forensic investigations, not only forensic investigations, but malware analysis with just the click of a button. All you have to do is to define your policy or upload your file, and once you do that, the information is provided, and you can gain insight into the different activities. So I want to thank you very much for taking the time to listen to this video or watch this video. I encourage you to get a copy of ThreatResponder so you can start exploring some of the capabilities, including threat protection or threat prevention, response, and detection, as well as doing forensic investigation and malware analysis with just the click of a button.